this thing on? I have no clue. I haven't been in this room in 2 weeks. But most of the stuff still seems to be working. Although I've had to wire up my mouse because it's empty and I don't know what's all broken and working or not working. But let's see if people can see me. Why am I in this view anyway? Let's go to this view. There I am. Hey there. Can you hear me? I need a drink. Today is some normal Coke, non-ultra flavor or whatever. John Kuster was first. And then Temes says, "Wah, surprise live." And John Smith is here, and Pat Demers. And Timothy Mason, "So glad I made the live. I usually miss it." Well, that's because usually we start about 2 hours earlier. But I had family engagements today and some other stuff I wanted to do. And I just got home from vacation like this morning or something like that. I'm kind of confused. And I was like, holy shit. Because when I came home, this box was there. And this is a box of components from LCSC. Interesting. And then it turned out that this box was also there. And that's a box from PCBWay. And combined, they form Ultra Force. No, combined they form a new prototype I really want to build. And I was like, let's hit the button. Mystery box. All loud and clear. Nice. Oh wait, I didn't hit recording. Damn it. See, I forget things when I don't do a scheduled one. So this will be a very informal live stream because nothing is planned. I'm just going to sit down and solder, and that's why I kind of made the unscheduled thing. If I sit down and solder and I feel like taking you guys along, well, that's this. So I hope you enjoy it, and if not, and you like the more scheduled live streams or the videos and stuff like that, hey, that's fine too. We do all those things. So who can guess what is actually this new prototype? Who can guess? I'm trying to see if I still have hints on my disk. I thought I would have, but I can't seem to find it. I probably put it in a way in the perfect spot so I could find it again, which means I lost it. That's usually how it goes. Good evening there, Sandro Moscati. So this will be a part... What the... Well, okay. My light flickered. I have no clue why. Everything still seems there. It's a bit dark on this camera though. Hold on. Yeah, that's better. No, it's not the new analog boards. Those have been technically designed and stuff. But they're waiting on some other things. Which I can't do too much on myself, so that takes a while. Alexa, flicker the lights. Yeah, I don't know what that was. That's never happened before, but maybe that controller is in need of replacing after, I don't know, 7 years of duty. Duty. Can no one guess? So the last time we left off the live streams and things like that, we worked on these differential boards. And then after that, like a 4-hour live stream, I believe we did, we tested something. And that was running power over the UTP cable using next to a differential signal to power LEDs very far away with a data signal and power. And we used, I don't know where they are. We used these kind of blocks for that, right? So to inject the power and take it off again and things like that. And I was like, during my vacation, man, that was awesome. So what did I do? I designed some boards around that. Now these are prototypes, and who knows, maybe they'll never go into production or in a very different form or something like that. But that's why you prototype. You test out a lot of stuff, and then you looked like you were going to cross over to the dark side. Hopefully not for the MGM in Vegas. What? Quinn light blinker, no. Anyway, you test a lot of stuff. Some doesn't stick or doesn't work, or you have to redesign and things like that. But that's why you test a lot, because then you figure that out. And if you don't test, you're never going to make the perfect version the first time. That's a wise lesson of Quinor for this evening. Make multiple versions. The second one, or iteration, I guess I should say, is often better than the first one. And also designing virtually, having it in hand and actually working with it will tell you things you can't really figure out from a screen. Anyway, I should show you this one. That's why I do so much prototyping, because, you know, I think it improves things. So we have 2 boards, and we're going to start with building one, and then we're going to see if I want to build another one, or maybe I'll do that tomorrow, and maybe I'll stream it again. Who knows? So this is the... Oh, they're heavy. The Quinn LED powered... Is it on there? Let me check if it's on there. I don't know. Oh, yeah, okay. Oh, I was debating between 2 names. I haven't figured it out yet, but I think I'm not going to use this one. So this is a Quinn LED data power diff, and I think I'm just going to remove the data and name it power diff, but I'm not sure yet. And this will take 48 volts to 55 volts in. It'll put it on the UTP cable with RS485 out here. And it'll also generate 500 milliamp of 5 volt, so you can power a microcontroller or whatever to put into the data input, which then will get powered and data out of the RS485 port. So you can run the controller using a single, if you have a 55 volt power supply, you can just input 55 volts, and then it'll output the differential, it'll output the 55 volts on the UTP cable and stuff like that. But it'll also output 5 volt, so that you can use that for powering your own microcontroller or whatever is feeding the data signal, right? And, well, this is what the top looks like. And I went for I guess a unique, I don't know if it's unique design, but we're using 3 of the 4 pairs in a UTP cable. So what I did is I designed the board around having a fuse per pair, so that whatever weird ass situation happens, the power, because it's 55 volts, right? Traveling over that UTP cable will be perfectly fused. There's some local capacitance here to smooth out power delivery, and there's all kinds of ideas implemented in this board, which, well, I guess we're going to see if that's going to work or not. Might not be today, because, well, we also need this board, because that's the receiver board. And we'll start with the sender board today, and then we'll, I don't know, I'll see how I feel. Because this, and I hope I did all this right, you never know. By the way, this whole stream is like revealing secrets, so there's no secret. This is a power diff, and that's why I like the name power diff better than Quinn LED data power diff, right? Just power diff is easier. Can we imagine some real smoke tonight? Well, if I made an error in this prototype, we're dealing with 55 volt and multiple amps. There will be smoke if something is wrong. Anyway, this board is a lot bigger. There's a reason for that. I'll show you in a minute. But it also has 3 fuses on there. It receives the RJ45 or the Ethernet here, RS485 in there. And then it has a power light per pair. So again, we have a fuse per pair, so also a power light per pair. Squadra Munter says, Dik de go werkt supergoed man. I like it. Thanks. Like hearing that. When is 55 volt common? Well, on PoE, it's often called 48 volts. but 55 to 57 volts has become more standard, especially with the newer standards. Anyway, 55 volt power supplies are pretty easy to get. I built in some status LEDs for if the buck converter is getting power, if there's incoming power. Buck converter? Yes. We're taking that 55 volt and you can transform, you can either use that directly, right? Supports 48 volt to 55 volt directly. And there's an arrow here. Then you have to connect this terminal to that terminal direct. Or you can mount a buck converter on here and that will convert it into 5 volt, 12 volt, or 24 volt. And we can do this up to about 100 watts effectively, up to 50 meters away. So let's say you converted that to 5 volt. That's what tests showed before. We'll see on this guy. If you do that with 5 volt, that's 20 amps. You can run some LED strips on that. Anyway, there's fuses on here, and there's more lights over here to see if the fuses were triggered. And then there's large beefy output terminals and level shifters and resistors and things like that. So I'm not calling this PUE because it's not official PUE. So I think I'm going to coin the term power diff. I'm here. What are we blowing up today? Well, we'll see. We're going to play with 55 volts and then see if it explodes. Anyway, so this board will basically feed into this board like that. So RJ45 out, RJ45 in, and then between here will be arbitrary length of UTP cable, and it'll transport LED data and power, and then we'll transform it here locally. Now, why is this board so much bigger than the other board? Well, that's something I haven't been able to verify yet, because I literally just unpacked these. So we're going to test that. I have, let's see, let's take this one. I have these buck converters from XWST, and they have mounting holes. And in theory, this will perfectly line up. Oh no, it doesn't. Does it? Let's check. No, it doesn't line up. So if I line up this hole over there, as you can see, then this hole is kind of off. Damn it. Let's try it from the other side, see if we can see it better. Yeah, we can see it better. So I think the hole spacing is correct, as in this side, but they're further outward than so the holes on the buck converter are further outward than I have my holes. But hey, again, that's why you prototype, right? Because I followed the drawn specifications, and well, the drawn specifications are wrong. But that's fine. This is a first prototype. That's something that's easy to correct and doesn't hinder functionality. But what is the idea? The idea is you get the board, because this is pre-assembled only. There's lots of small components and things and stuff on there. And then you get some M3 posts, and you basically mount the buck converter on top. Let me put you on the big screen. There. So you get the board and with components and things like that. And you mount the buck converter on top. And, wait, it's the other way around. Oh, maybe that's why. It's the other way around. Is it? No, it's not. It's just spaced differently than it said on the website. Damn it. Anyway. No, it should be this way. Yeah. And the idea is you line up the buck converter, but the screw terminals on this side, they protrude, so you can still reach these screw terminals. There. So those protrude, and you can still reach those screw terminals and see those LEDs and stuff like that. And in reality, this buck converter will be slightly higher, of course, than the board. And it'll be a nice sandwich, so you can make 5, 12, or 24 volts. And this is a very high power version. Maybe at some point I'll make a lower power version, which then also would be smaller. But I don't know, maybe. Who designed this board? I did. Yeah, 20 amps should be possible, I think, and that would be very reasonable in regards to power delivery, I'd say. So today, we're going to be building this board, and this is fully custom. So there's a fully custom buck converter circuit on here, and everything else is fully designed by me. On this side, I didn't want to mess around with designing a 20 amp buck converter and then needing a heatsink and stuff like that for it. So that's why I'm using a pre-made module here. Maybe another voltage model is differently spaced. I don't know. Let's see here. Yeah, it is slightly differently spaced. That kind of ruins my idea, guys. Why would you do that? I don't know. I'll figure that out later. But the idea is you buy one of these sets. These will always be 1-to-1, so there's no multiple or midpoint boards like on the other system where you can take 1 or 2 channels and then break them out and form a chain. These will always be 1-to-1, and it's a custom ecosystem or whatever you want to call it. QoE. Yes, we're calling my standard QoE. I don't know, man. Misalignment will definitely help with releasing the magic smoke. Yeah, we'll try and put some posts in there once we reach this board and see if it's bad enough or not. And maybe I need to make 2 whole notches to accommodate them in the real version. Things like that. We'll figure that out. But today we're going to focus on this guy. There's a fully custom buck converter on there, fully fuse protected and things like that. And as I said, the 3 fuses for each of the pairs, and there's LEDs and lots of stuff to put on here. So yeah, maybe later, but probably tomorrow or something like that. Or maybe I'll just do it on my own. But generally, I like taking you guys along, right? And there's 55 people here that randomly showed up when I hit the live button, so I think you guys also like that. Right, let's put this back into the box and get a stencil out for this guy, for this one. There. Yesterday, I ordered 2 brain boards and 2 Octopower 7 boards. Awesome! I do not know how to pronounce a name like that. Core count was out because he was on a beer run. I don't get that because I drink Coke, but I get it for a Coke run, you know. You bumped the watch button while reaching for an adult beverage. That's as good a reason as any. Right? Let's get another one because this one's probably smeared. Yeah, don't, you know, I'm not good at taking holidays, so I went to Croatia for 9 days. And suddenly when I'm home, there are new boards, which I couldn't have designed before I left. Shh. Don't tell anyone. You know, I don't know how those got there. They just magically formed. Oh my god, okay. They just, you know, they happened to be waiting at home when I got home. It's very surprising. So let's get the, oh, no, okay, yeah. The plank out. Oh no, my mouse is clicking on stuff. There. Aw. Too bad. Okay, yeah, I got enough room. Have Quinled dig quad boards previous revision. Anybody has the same? Those 2 transistors always hot. If you have an older one where you have the 2 upstanding linear regulators, so they go from 12 volt to 9 volt to 5 volt, those will always run fairly hot, and that's why it's also not compatible with the Ethernet version and things like that. In later versions, and you can check the version history for that, I changed to a buck converter design and that, well, basically alleviated that issue. And in another later design, we also added 24 volt support, things like that. So this is kind of in here. Lately designed power injection, LDPI, yes. How are we going to do this? Something like this. Yeah, that seems good. There's also an Ethernet, or an Ethernet. Well, there's an Ethernet jack on there, but there's also a USB-C jack on there. There's no correct links to 24 volt strips. You mean for the analog or digital, or... There's lots of links on there, so... A late night surprise, Quindor. Hello. What's up, Quindor? What are we soldering laying out today? Laying out? Digital RGB. Well, those links often change, so I'll check them again. Prutsing is a Dutch word. Yes, I think so. How do I want to do this? I think I want to do it this way. There. You smell DIY. Now let's perfectly align it. For fun, I went with a red color. Oh no. A red color this time. Of course, in reality, it doesn't really matter. Especially for a prototype. But I'm not sure yet when I want to make the production board, if this goes into production. I think so, but it all depends on how these prototypes work. If these prototypes works well, it's likely that there's going to be some production at some point. I love DIY. Making custom PCBs. Yes, I make a lot of custom PCBs. Unexpected Maker had magic smoke and flame. What? He does that while I'm on vacation, so I couldn't watch. So I'll have to rewatch that stream, that's for sure. It's not stable. No, I'll try it anyway. Should be okay. Ah, this is what I was looking for. This is what we did last time. With these extractors and thingies and stuff. We are working on Quinled power diff. So it's a prototype for sending power and data over a UTP cable. So we're going to be making two boards, probably not today, but you know, in the end. And that is a sender board and a receiver board, kind of continuing on the differential theme. But, you know, we'll do the sender today and then probably test that a little bit. And then maybe we'll do the receiver. Probably not, but, you know. Okay, let's paste this guy up. That's pretty decent. I'll take it. There's not too many small things on here except for the USB-C, but that only needs a tiny little bit of solder, so please pruts the paste evenly. Oh, this looks pretty good, I think. Well, let me put the excess back into the pot. Close enough, TM. You know, that's how I often roll. It's okay. Well, during prototypes, not, for the design, but... So let's clean this off real quick. Everybody's having magic smoke. What? In theory, it should work. Yes, and that's when you build a prototype. Cool there, John. Happy to hear that. Okay, let's see how we did. And there. I'd say that is definitely close enough. Right? Some pads could be slightly cleaner over there, but that's not going to matter much. Even the USB-C is pretty good. Yeah. Okay, let's clean this guy off. If components fall off when you flip the board after reflowing, then you know you didn't put enough paste there. That is absolutely true. We should get one of those wall tiles for in the toilet. If component falls off after reflowing, you didn't put enough paste on, moron. Okay, let's get this guy out of here. So the other recent prototype boards were a differential data only, but these can send power along also. Yes, that's correctly right there, Brandon Stargrave. This is just testing, Not sure if that'll become a product or not, but I'm hopeful. Yeah, but that's exactly the idea. But it'll be one-to-one only. So one channel of data, and then the rest is power. Where, for instance, with this system, we have a 4-channel data output, and then we have these midpoint 1 and midpoint 2 boards where you can extract channels and make a chain and things like that, right? So in that sense, it's the same concept, but it's also different, and they're not really compatible with each other because you can't send power to this one because it's expecting data on all pairs. So yeah, imagine the heart surgeon. Yeah, that's close enough. Stitch it up. yeah, I get it. I think I want it like this. Let's see if my mouse charged up enough already. I hope so. Okay, let's focus that. Let me get the BOM file. Do we want the BOM file on screen? I guess so. Hold on. Yeah, our Pro, generally we give it a little bit until we know it's a good working version, and then we also put it on the website and we update everything. I'm not sure where to place the BOM right now. I think something like this would work. But then I have to move this. I guess I could move chat down. There. How's that? Is that a good layout? I think so. Let me check on my phone. Okay, that's good. Yes, this is a send board, and when I already put it away. I showed it earlier. There will also be a receive board. That's correct. Right. Let's start with putting on components. I don't need this right now. It's going to be a mix of components I already have and new components. So somewhere on the packaging there should be a big sticker designed in the Netherlands when shipping products all over the world. Never thought about that one actually. Maybe. Does that add value? Let's see here. 2.2 100. I might actually have these here. No, but I'll need it later. And no, but I'll also need it later, I think. Yes. Okay. Oh no. Right, where are my 1206? Okay. 1206 capacitors. Oh no. Timbo is here. It's been about a year since I caught the last live stream. What additional products have you released since the Dig Quad, and what do they do? Whoa, that's a lot to go over. I released the Dig Octa series, which has a brain board, which has Ethernet and SD card and all kinds of stuff. And it's a stacking system, which can stack with power boards, which I also released. And then there was the Dig to Go, and then there was some updates to the Dig Uno and Dig Quad, I think. I'm working on a whole analog product line, and now we're working on differential stuff. Lots of stuff. So that's a bit too much to just, go into right now. Right, we need 3 of these. I dropped 3, I see 2. Okay. Okay. Yep, that was good. Why am I starting with 1206? Oh, interesting. Okay, I need some 1210. Then 4.7. Yep. Not much then. Well, there's lots of stuff in the works also. I think you're joking, but yeah. Okay. Well, maybe, Emil. There's lots of nature parks we went to, and we walked around and things like that, so that was cool. Lots of waterfalls and other things. Why is this sorted this way? No, I'll look at it later. 0805, 1, okay. If you didn't know, part of this stream is going to be Quinled searching for parts. What? Quinled not finding parts. Why did I do that? Alright, keep searching. Yeah, okay. No. Well, this part needs to change. Do you have an inventory? Not really like that. Let me make a note here for myself. Oh wait, you can see my notes. That's not good. Let's put the notes here. Power diff. Okay, so we're going to exchange the first part already. It says I need to use a 0805 100 NF or 0.1 UF in 0805, but that should have been 0603. I don't know why it's not, but we're going to use an 0603 anyway. And let's hope it fits. So let's see if we can get this guy here. Yeah, that'll probably reflow okay. That's fine. Cool. Why is it sorted all kinds of wrong? It'll swim between the contacts. Yeah, exactly. Let's see. Do I need any 1206 or 0805s? No. Let's see if there are any down here. There shouldn't be. No, okay. Good, good, good. Then this box can go. So, then, let's go for 0402 stuff. 16. Oh, wait. I always forget that I order new components with new boards. And then I don't check the new components. I'm like, why don't I have this component? It's probably in the box with the new components, but I kind of want to change that component to this component anyway, so I'll do it this way. Right, 1 UF 16 volt 0402, capacitor 0402, 1. This is 10 volt. This is 25 volt, that's fine. Yep, we'll do it 25. I need 2. Probably, and otherwise we'll nudge it a bit. Wow, this one doesn't want to go where I want it to go. There. And where else? Over there. Okay, and we need a 0.1. 16. You get nervous from 0402? Well, I use the best capacitor size for the task. There's multiple reasons to go with various sizes, so... Sure. And it says I only need one, but I can't believe that. Because there's, for some reason, some hidden down here. Is there any 0402? No, there's not. Okay, then I don't need more. Good. A same value in a larger package won't hurt, won't it? Actually, it does change the characteristics. Characteristics, yes. Slightly. So, in theory, it's fine. In practice, it does change things a little bit. So a 33 NF. Music is a little bit loud, isn't it? There, tone it down. Exactly, Berend. Do I need any more 0402? It's stupid this list isn't sorted. Nope. Okay, that's good. Then we can move on to 0603s. What, 16 volts? Ha! First try. Ah, there's a mistake. Can anyone spot the mistake? It says to use an 0603. That's correct. But then it's an 0402 pad. That's not going to work. Well, it's going to work for the prototype, but, you know, I should correct that. C20, wrong pad size. It'll buff out. Let's see here. This is an 0603 also, but 10. And then 16 volts. Do I have that? Yes. It's more important for RF, yeah. Okay. Now, what's supposed to be on here? Resistor, resistor, diode, diode, resistors. Also, yeah. Okay, then I think we're done with the capacitors. Except for the big cans and stuff like that, but we'll do those last. Okay, right. Let's see here. Okay, so I need my book for that. Ooh. Stay up there. Okay. We need a 24K, but that's a totally guessed value. But we'll go with the flow. No! All my tools are crashing down. Stay up there. Let's see if my little book of resistors here has a 24K or something equivalent. It has a 24K. Oh wait, of course, no. No, I probably ordered a 24K. Well, I'll use one for my book now I have it. Why do I even order components if I'm not going to use them anyway? Okay. I can't see where they go. Hold on. There. Oh, right. Oh no. Okay. Let's see if you guys can still see. Yeah. So those are some resistors for some LEDs. That's why I said the values are kind of guessed. Yeah, sample book. Yeah, sample book always saves the day. I have sample books for 0402, 0603, 0805, I think. I don't have 1206, I think, but they come in handy a lot. Let's see here. Resistor 0402. 5.1. Yeah, exactly, Emil. No orientation worries for resistors. I need 2. That. Oh, okay. That's easy. There. 56, I think I also have. Yes. And I need 2. Okay. Sure. Okay. Okay, we need one of these. Those I have over here. It's easy. there. And then we need a 51K 0603. This is an 0603. This is all other stuff. Okay. So we go to 0603 resistors. Oh, there's a little spider here. Resistor 0603, and then I need 51K. That's probably in my normal pins. $16.2, no. 51, okay. Yep, 51. Spider wants to get reflowed? No, I don't think so. 51, right? Not 56, yes. No, it ran away once it saw me. Of course. Yep, that's correct. Now, 16.9, I know I don't have in my normal values yet. I should put it in it. No, I'll do it later. So let's take a look at the box. The box of goodies. Oh. They almost put it in a big bag, which makes it harder to use. Let's see what we need. 16.9. Damn it. Of course they don't note it on there. So I'll have to look all these up. Okay, so this is an 0603. That's a high chance. Let's see here. 0402. Yeah. 0402. Oh wait, 16.9 of... Did I use the wrong footprint again? It's possible. It's very possible I used the wrong footprint again. Let me dig through this a little bit. Because there's other stuff in here we need. Probably this guy. This guy for sure. The rest I don't know. There's no more resistors in here, so we're gonna look up. We're gonna look up these bags. Let's see, part number C2770651. This is a 16. Oh, but it's 0402. Damn it. Okay, well we can use that as a substitute if we need to, but I also have C25954, and that's also a 16.9, but an 0603, which is exactly what we need. Cool. I'll label this some other time. Don't you ever run out of storage for all those boxes? Absolutely. I've already been thinking of how to fix that issue. Because I keep getting more boxes, because I started with a single 0603 resistor box, but now I have an 0603 low and a high resistor box. And I used to have combined boxes for some other stuff, but now I have individual boxes for, you know, those things, and yeah, the problem keeps getting worse. Okay, let's go back here. Let's see. Okay, yeah. But I kind of also need a different room, because if I do this, I can almost touch both sides of the room. This is just a very wide lens. It's all to fool the audience. Quinn storage. Well, I already did projects with that. So let me get an orange LED. No. Queen House project coming soon. Well, oh wait, I need 3. No, that's the orange one. We've actually been looking because we can't really expand here, so it's not that far from the truth there, CJ, or Queen Basement also. Those are all things being considered. Where does this go? Okay, over there. Where's the dot? Is there a dot? Oh. Okay, but I know where ground is. So I think it needs to go this way. Let's go. Okay, that's done. Now I need to find my blue LEDs, but I also need to find my diodes. And I think those are in the same box. Well, maybe they're not. There's a box called SMD LEDs. Hold on. Oh no. Okay. Well, yeah, the current house has been built to spec, but designed like 7 or 8 years ago, and kind of the requirements have kind of changed. So we have enough living space, but now there's also a business, and that complicates things. Right, let's see here. Oh, I figured I'd have these LEDs, I think. But I don't. Maybe in this pack. Orange. Green. Well, if green is the right size, orange. Green is the right size. Okay, we're making it green. Dig under the chicken coop. Well, it's actually something we've configured or considered and looked at. So, as I said, that's absolutely not far from the truth. These, okay. Because we really like the house, but as I said, there's now a different purpose for some of the stuff, and it's not really designed for that. So, yeah. Let's see here. 1, 2, 3. 3? 1. Okay. 3. Let's see here. Okay, yeah. Wait. No, okay. I need to turn this one around, I think. I always mess up these orientations from LEDs. Okay, that should do for now. So that's blue, which we turned into green, but you know. Do you use the large hot plate? No, not for this one. I think we might still need one from this guy. Let me get it real quick. Nope, that's been moved to. Has it been moved? Oh, it has to. Huh. Yeah, it's been moved to a different box, but I didn't remove the label. Bad me. That's bad. Bad me. Okay. Okay. Let's get that real quick. Please remind me, after we do the reflowing, I test these LEDs so I can quickly reflow it again if needed. Because I'll probably forget. So remind me to do that. Okay. Let's put on this big component already. Go away. That should be my custom footprint, which should fit fairly well there. And let's take that off there. No, I don't want to do that yet. I'll want to do these because I think I have them over here. Do I want to use these? Oh, sorry. I guess so. That's good. That's the buck converter. What? That was a spider? Oh, you mean this is a defective spider? Okay. Okay, I have this back here, so let's put that on. And let's see where pin 1 goes. Pin 1 goes over here. No. What? Oh. Okay. I think that's all correct. Hold on. I poked the resistor. Which one? Well, we'll inspect it with the microscope later anyway, so. Okay, I need 3 of these. G3. Don't see it. 4? Well, we'll be checking everything with the microscope in a minute. Okay, let's do that one. Is this an... No, this is not the right... This is not the PTC you are looking for. Nope. Searching through the box. Close. Okay, yeah. Nope. No. Did I put the wrong size? I might have. Hey there, Luke. Good evening. Let me check one time more in the box. Hey, kitty. The cat's back. So I'll need this one. Oh, I just labeled it wrong. Yeah, I labeled it wrong. Okay. Oh, that's good. Perfect. Oh. Hey there, Fenatech. So I labeled this a 60 volt. But it's not supposed to be 60 volt because it's in a 5 volt path. So I'm using a 16 volt, which is fine. So if cat is back, spider will definitely be loud. Yeah. Later, Emil. Thanks for hanging out. Yeah, it's late here in the Netherlands. I did there, Fenatech. Let's see. We still need a big capacitor, a small capacitor, a USB-C socket, and a inductor. Let's do the inductor. All right. And now let's do the big capacitors. Where would I have that? SMD high voltage. And this should be 100 Oh, wait, no, this is the wrong one. Ah, right. Yeah, it was 33 100 volts. I think that's this one. Okay. That should be good. Right, but this isn't the high voltage one. Yeah, I almost can't reach it anymore. 35 volts, 100 UF. 680, that's too much. That's too much. Okay. We'll fix that with the microscope, I guess. And then I think we need a USB-C connector. And then we have completed all SMD components. Now, where did I put my USB-C connectors? Did I change that? No, I don't think so. So later we'll need one of these yellow UTP connectors. So let's get that. Yep, USB-C is here. Okay, so we'll need that at some other point. There. Oh, no. Don't you love those bags? Yeah. Okay. So then I think most of the stuff, or at least all the SMD stuff, looks green. And we only have like this big terminal here, and this RJ45 here, and a big through-hole capacitor here. So we'll get the microscope out and check all the orientations a little bit. Let's turn them on. Something just disconnected. It's always interesting. Let's turn on the microscope. Let's turn this guy off. Yep, microscope is booting. I need a stable surface. Nope. Something. Huh? Yes, good. Okay. Let's move this up a little bit, because then I can inspect everything. Okay, let's nudge some components a little bit. There. That's fine. The little 0603 we put there instead of an 0805, but that's fine. Let's move this one slightly out of the way. And that's good. That's good. Let's take a little bit closer look. Well, that should reflow okay. Here we have a too big capacitor instead of a too small one for this pad. But that should still reflow okay. This one needs to move a little bit. There. The USB-C is basically always generally good aligned. That's fine now. Okay, this guy's off. There. Those are good. That's good. Meh. Better. Great. Oh, this pad almost has no paste on it anymore. Hey, Chordo. Okay. Yeah, that should do fine. These should all be fine. Okay. I think we're ready for reflowing. My room is so overcrowded. Ugh. Let's get this guy. I, of course, want to see the reflow. Duh. So let's get this out of the way a little bit. Okay, this. There. Let's turn that on. What are we listening to? This is music from Approaching Nirvana. Don't know the exact song name, but all the music is from Approaching Nirvana. You should check him out. He makes some very nice music. Maiko, no, it shouldn't touch because there's solder mask there instead of a pad, so it should automatically draw to the pads, basically. We're at 46 degrees. There. And now we wait. I like that. You can't not do a slurp if it can. Otherwise, you can't get all of it out. I mean, what are you supposed to do? Happy New Year, what? Good evening. Missed the notification. Well, it was, you know, a spur-of-the-moment thing, so... Soldering in ASMR mode. I like watching the solder melt. I do too. We're now at 103, so it's activating the flux. Yes, this is low temp paste. It's 138C, so 138 degrees. Smoke! Yes! That's good smoke in this case. Mirage heat waves in the camera. Yeah, yeah. It's still pretty far up, but, you know. Okay, we're at 152, so most components should align now. I'm going to check with the magnifying glass, and then later we'll check with the microscope too. Right, so we have a resistor here that doesn't want to do what it should. There, now it does. This all looks good. Even our little bodged one there looks fine. That's on its pad. These look good. Oh, we have an issue here, but I can't really see it. Hold on. There. That should do it while this remains correct. So, okay, so the big one also aligned. That's fine. The 0603 and an 0402 pad. Check the LED. Which one? No. We have to check that after reflowing. If the polarity is correct. But they are correctly reflowed, so that's good. Yeah, that looks good to me. That's good. Yep, that all looks good to me. Is there an obvious error I missed? I'm going to check on the screen. No, looks good to me. So let's turn that off and transfer it to my pad here. William, there is an article on Quinled.info. If you go to the digital LEDs, the Digital Addressable LED section, there's an article there, how to connect a microphone to a DIG quad. Cork for the win, exactly, right? So let's turn on this camera again. And let's give that a quick inspection. Oh, this big capacitor got kind of screwed. Can I still move it? I can, but it's hot. There. Okay. Ow. Okay, that's fixed. That's fixed. Okay, that looks good. That looks good. that looks good. Let me give the USB-C connector a push while it's still hot. Fine. We'll check the pins in a minute. That looks fine. This is all aligned. That's all aligned. There's not too many components on here. I'd say generally that looks good, so let's take a look at that USB-C. No, other way around. So let's take a look here. Okay, I'd say that reflowed pretty good. All pads are making contact, no pads are bridging. Cool. So, good. Then I can put the microscope away. Well, I'm going to keep it here for just a second, because we're now going to do what you guys were going to remind me of, and that is check the polarity of the LEDs. Right? Let me turn that around again. There, let's put this on continuity mode. And I'm going to fix that for you. There. And I'm hoping we put these the right way around. We might not have. So far it's not looking good. So let's do that in reverse. Yeah, okay. So I put these the wrong way around. Of course I did. Well, we'll fix that. Over here. It's also the wrong way around. Wow. Well, at least I consistently put it the wrong way around, right? There's something to be said for that, I hope. So I'm putting it back on the hot plate. Let's wait a second for that to heat up again. Okay, let's wait a few more seconds. Right, so now we should be able to basically turn these around. That's one. That is two. That is four. And that's five. Oh, no, wait, that is four. Breadboard friendly ones. Oh, I wouldn't really know, Morton. But maybe we can discuss that on the Discord. It's a bit hard to do that on a live stream. Okay, so let's get this off on onto the cork again, so it can cool off. There. Well, we can check it on under the microscope one last time, just to make sure. course, there's a little bit of flux mist there now, but those look fine. Yep, this looks fine too. Cool. Also, okay, let's get this hot plate out of the way while it's hot. And I need this guy. We don't need the microscope anymore. Fume extractor, yes. Yes, it's a good plan. Because we need to solder a few through-hole things too. We're going to use the solder I unpacked during the last Quinn box, but I noticed already that some people reported that they can't get it in their country. There's not too much I can do about that. Some of the links actually disappeared, which is a bit odd. But yeah. Okay, let's turn that on. Let's get the components for that. One of them is this guy. So, that's, you know, the RJ45 plug. That should okay. It's still warm. Let's get the other components. Nothing moved, right? Okay, nothing moved, so it was cooled down enough. That's good. Okay, let's get some plugs. RJ45 was conductive? No. Well, it will be. We need 3 2-pins. Oh, it passed the heat through to my hands. No, that was the board I was holding, but... Okay. Oh, and we need one big capacitor, but there's one I want to test, which is in my box. Yes. So let's see if these all fit. They do. Can I already touch it? Oh, okay, now I can touch it. This one goes here. I always like to pre-fit it, so then see if I indeed have all the components. And this one should snap into place. Yep, like so. I'd say that is all components. I know it's not perfectly in focus right now. This worked out okay. Alignment's pretty good. Right, so this is the highest part. But I don't need to worry about that guy. Okay. No! I need to do my cork twisting trick. Do you hate putting RJ45 plugs on Ethernet cable? Not too much, it's okay. I recently did like a whole spool of 305 meters with new plugs. But they were pretty long ones, so. Okay, fume extractor time. Yep, the big tip is on there, good. Oh no, you can't see. There. So we're going to do one one leg of each connector. And then we'll do an alignment check, because this always happens. This one's pretty good. But what I do is I hold it and then I reflow what I just did. So you also take the connection, like the data in, instead of the ground connection. Right? And if you hold it like that, you can push it in while you melt the solder and align it perfectly. Like that. So this is now good. Let's make sure this one's pushed in fully. No, these are my prototyping connectors, and those don't have Phillips screws yet, but once I order them for production, I can specify whatever screws I want, so, yeah. Right, so capacitor. We'll also do one leg first. No, not posy for a screw terminal. Okay, that's pretty good. So let's do the other one. This is a ground connection, so it's going to take a little bit more heat for it to take well. That should do it in theory. No, these aren't bridges. Oh, right, I still need to do the others from the screw terminal. Oh, and I also need to do the USB-C side. So, ground. Yep, that's good. That's good. Okay. Yeah. And to give the USB-C connector a little bit more rigidity, I'm going to melt some solder into there. Okay. And if that went correctly, that sort of soaked up a little bit. Should be good enough. So, let's see if we have all the... Oh, wait, we still need to do the RJ45 connector. Let's see here. The legs of the capacitor in the way. There. Okay, those ground connections need a bit more thermal relief. Come on, light. What are you doing? Okay, so those don't want to solder properly with this soldering head, but I can try and get it on there. There. Saw how it easily went? Awesome. Big soldering tip to the rescue. It's not a perfect job, but it should do well. Oh, this is 0.6 millimeter, so it's not that big. Ow. Don't do that. Come on. No, we don't need IPA for a prototype. No, if you're using Q1, you can only use Q1 once, so for Q1 or Q1R. But you could try some other combinations. The ones listed are just known to work. Not all combinations work. But yeah, they'll take a little bit of figuring out. So let's put the tweezers away. There's a giant mess of components here. I'm just gonna scoot it onto the side. Okay, let's snip it off. And then we're almost ready to test it. Okay, didn't solder the capacitor on great, but let me make a note of that. Okay. Do you have a power tweezer for the LEDs? No, I just use my multimeter. I'm just taking a last look at the board before we apply power. Just writing down some notes. Right, let's get my cable here. Oh, this one doesn't have any ferrules. Why not? Well, I guess we'll use it without ferrules. Blasphemy. Blasphemy. Let me zoom this out. Okay. Right, so positive and negative is pretty easy because here it says 48 to 55 volts. It says VCC on top of here, and then I always use a white block basically to note ground. So the two most inner are ground, and then the right one is data in. But we're why is this cable so sucky? I need to make a new one for this. There, because I want to have it this way. Magic smoke coming up. Yeah, we'll see. We'll see. We're gonna put it to 55 volts. We're gonna put on the glasses, because who knows? Maybe it'll explode. There, glasses are on. Let's limit it to 0.5 amps. That sounds reasonable, doesn't it? Yeah, so we can all see. So the first thing we're going to check is if we see the LEDs come on. Power. Oh! Yes! Yes! Very good! We have 3 green LEDs. There's still a lot of power, yeah. But it's currently drawing 0.01 0.01 amps or 0.54 watts. That's in expected lines. And so we have a power LED and we have 3 green LEDs, which is also expected. Nice! Okay, so let's do some measurements. Each one is for a different pair. So what these green LEDs do, I guess I can lose the glasses. What these green LEDs do is power online for each pair. So pair 1, pair 2, and pair 3. And each has their own fuse. So if one of these green LEDs turns off, that means that fuse closed, basically. PoE into this board, nothing happens. In theory not. Output into Ethernet device that expects PoE, bad time. Yes. Do not connect this into your switch or anything else. So, yeah, so let me get the multimeter view up. Yes. A visualization of the fuse condition. Yeah, that is correct. Let's see if that works. Yes, we have multimeter power. Because on this terminal, there should now be 5 volt. Oh, right, I'm holding my probes wrong. Yep, 5.02. Very nice. And, well, if I take a ground... This board doesn't want to stay put, huh? If I take a ground and I probe here... 54.96, that's correct. And over here... Yep. And over here... Yep, all good. That all works. Now, something I've always been wanting to try, I generally make USB-C input ports, not output ports. So I want to see if I plug in a USB-C cable on this side and take a Quinled LED module like here, if it would power it. In theory it should. It does. Nice. So now we're providing 55 volt into this board, but we're making 5 volt for multiple reasons, and one of them is an output port, and we're doing that by USB-C to this little guy. And well, I haven't verified if it's actually online, but it should be. It's only 500 milliamps, but that should be plenty to power an ESP32 or a different Quinled LED board to function as the data input board, right? I thought it would be a neat feature to include, because generally other hardware doesn't run on 55 volt. So, you know, let's get the thermal camera and see what that says. Thermal power. I forgot I put myself on the other side in like a... Oh, that was when I was recording the other Quinn box. But I keep getting confused why I'm on the other side. Hold on. Let me move myself here. And then move the chat up again. There. Is there PoE on the RJs? Well, we'll have to see. So let's see here how warm things are getting. Wait. IR. There. So on this side of the board, nothing is getting warm. Okay. Here there is a little bit of a warm thing. That's the RS485 chip. That is to be expected. And then over here, we have 3 LEDs and resistors, and those are getting slightly warm. They're 55 degrees. That's still acceptable and okay. I might need to lower those values to make it a little bit lower, but still. And then we have the 120R termination resistor for RS485. That is also 51 degrees, but that's also expected. So how do we test that? Well, I think we're going to use one of these contraptions. Because in theory, these are the ones I used on the previous live stream. And I think I need the other one. I don't remember. Nice contrast. Yeah. These are jank AF. But I need to check which one is which side. I don't remember. But then again, there's nothing connected, so it can't really blow up. Let me get a short RJ45 cable. I don't have a short RJ45 cable. Let me get a really long-ass RJ45 cable and tuck it in here. Are they real Wago? No, these are a Chinese clone Wago. So let's plug that in. No short circuit yet. Let's use this one, I guess. I don't know. Come here. Oh. I don't know what that did, but it drew half an amp. Why? Why would it do that? So let's disconnect this board real quick. I don't want to break that one. Did I use different pairs? No. Let's try that again. That's often the best way, right? Yeah. It draws half an amp, but is it allowed to draw half an amp? Yeah, no, the current is limited at half an amp, so that's not a problem. Let me check what's going on here. Are we getting power? No, we're not getting power to the other side. So something is definitely wrong. Oh, the board is also turned off. Okay. Yeah, that's probably because the PTC input limiter got triggered. That's why it's there. Well, let me try the other side, basically, because I know I wired these up correctly at the first try. Let's see here. Nope, same thing. In theory, I think it's the power supply currently limiting it, but Okay. I don't understand. There's nothing... Need to think here. What's going on? I guess we could probe the pins on the RJ45, but that's very finicky. Oh right, yeah. Let's disconnect power. That's a good suggestion there, Cyril. Now let's connect it. And then let's beep out the positives, right? So this is all positives. Is it reversed? Oh wait, we're not in beep mode. Beep. Oh, please exit remote mode. Oh. Hold on. So this is connected to positive. This is connected to positive. And this is connected to positive. That's all good. But ground is also connected to positive. That's likely not good. I know what I did. Okay, bear with me. So we can disconnect these. No, I know what I did. I followed the official specifications, while on this test plug I didn't. So, Ethernet, if you look at the pairs, is 1 and 2, 3 and 6, 4 and 5, 7 and 8. So 1 and 2 is empty, because that's data. And then 3 should be positive, and 4... 1, 2, 3, 4... Let's disconnect these. So 3 and 6 are a pair, and 4 and 5 are a pair. But 3 is positive, I think. I think I wired it up that way. These can stay. So 3 is positive, that's good, that can stay. But 6 is the negative of 3. But because remember, when you're making a UTP cable, you always have to break apart, I believe, green, and then split that over, 2. That's basically what this is also. So pair 1 is 1 and 2, pair 2 is 3 and 6, pair 3 is 4 and 5, and then pair 4 is 7 and 8. So it should be wired up like this. So pair 1 positive, pair 2 positive, pair 2 negative, pair 1 negative, and then pair 3 as a whole. So let's beep that out. So let's put it in positive here. Well, it's a lot more resistance now. So that's, let's see. Yeah, that's low resistance, low resistance, low resistance. But this is probably a capacitor. So let's check here. No. Oh, wait, yeah. Why? I'm going to try it anyway, because it might be a capacitor. Yeah, exactly. I think it was a capacitor. It works. So now it works. Yeah, no, but I just tried it. It's okay. There's all kinds of protections in there. So now the board is online while we have this one plugged in, right? And so we should be able to measure DC. Oh, exit remote mode, please. DC voltage. We should be able to measure 54.959 on the other side. Excellent. That also means there can't really be a short anymore, because otherwise that wouldn't make it over the cable, right? These little lights are on. So I don't feel like soldering the other board, I think. Let me check something real quick. Yeah, soldering the other board's probably going to take another few hours, and I think I'll leave that till tomorrow. Not sure yet. Do I want to? What is it? 1:30? Is anyone still here? Do we want to solder the other board today? Right now? That terminal block's making my OCD trigger. Yeah, that's why we're going to replace that with a PCB. Now, one of the things I want to do for fun, while we think about, well, I think about if I'm going to do this today. Oh, yes, a poll. Okay. Let's start a poll. Will you stick around another 2 hours? There. Yeah, 133. Yeah. Okay. So let's try something. Let's raise the power limit to 2 amps. So 55 volt, 2 amps. And I'm going to turn that off real quick. And then we're going to disconnect everything except one pair. Well, that's good enough, Maiko. Only one Coke done. That's true. So now we're going to have some fun, right? While we think about this. Because we're going to test if the protection mechanism works. So that's a very important test, of course. I mean, maybe it's the most important test. Right, so wires are back in. Board's hooked up. We now have a power limit of 2 amps. But these PTCs are 750 milliamp. No, we're not going to purposely connect it wrong. We're actually just going to bridge it with a wire. I guess I should put my danger glasses on. There, danger glasses are on. Are we ready? Because I'm just going to short it like... Oh, wait. Okay. So, 55 volts coming in. It's going... that is actually not going through a PTC. It's directly going to these 3 PTCs and capacitor. And after that, it goes to a capacitor and then through the UTP cable. And then all the way over here. And we're going to short it here and see if the PTC reacts. So, let's see. Positive and negative. Okay, it's drawing 2 amps. Oh, yeah, there he goes. So now it's only drawing 0.04, but still 2 watts. But one of the LEDs is now off. You see that? I need to keep applying pressure while I try to lower the lights here. Hold on just a second. There, now you can see the LEDs better. So one of the LEDs is off. right? So pair 3 is now off. And if I release this, now pair 3 is on and providing power again. But if I reapply the short, it first dims down because it's power limited, and then the PTC kicks in, and now that pair is no longer providing power. The PTC recovers almost instantly, although it does depend on the draw that's on there. Right, so I'm keeping the short in there. We're currently seeing 0.04 amps or 2.19 watts. It's still a little bit of power, but, well, as you can see, the LED is actually just off. And now I let go, and it instantly powers on the LED again, but really, depending on the load, it'll take a little bit. Yeah. So let's let that cool down a little bit, because if we take a look at the thermal camera, if we take, oh, we can't even see it anymore in the thermal camera. It's already cooled down. You can't see, but that's okay. Well, sure, but it should still function. So let's do that once more. So currently all pairs are providing power. And it's gone. Now let's try it once more, and I'll set an insane amount. I've set the power supply to 55 volt, 10 amps. That's going to be interesting. So, let's see what happens. Okay, right. That's better. So now, because it's able to draw 10 amps on the input side, the short is so big that it basically instantly triggers the PTC. Because it's not hot, I think. No, it's not hot anymore. You need to double goggles. Yeah. So let's trigger it. I can't reach it. Oh, wait. I can do this an easier way. I just need to put this in here. There. Right. So let's trigger that short circuit real quick. There, and now it instantly triggers, and like, and now if you look at the board, you can see that the PTC is 106 degrees, or you can't. There. You can see that the PTC is really hot. That's because it's triggered, and once I release that, it basically drains away pretty quickly. And that means the resistance is going down, and so it's conducting again. Don't bring your whole house down again. No, that's okay. So yeah, basically when there's enough power, that's pretty instant. Right? As soon as I actually short it, it basically turns off. And I can't even see a very high draw on my power supply because it's gone too quickly, basically. Right? And in theory, if I now... Let's turn the power off. If I now move these cables... Yeah, we'll look at the pool result when I'm done playing around. If I now move these to another pair... Oh. There. Okay. I'll end poll. End poll. We're at 67%. Yeah, 66% yes and no 33%. 27 votes. I'll think about it. Okay. Apply power. And now, when I short it, it should short another PTC. So that one should go that one should turn off. Yep, there we go. Now the middle one is off, right? So that's basically a protection mechanism for two things. One is if for some reason the cable gets damaged, or somebody puts a spade in it, or something else happens, this is just a protection mechanism to make sure that it can't suddenly draw 10 amps and basically fry or burn the cable and turn it into a fiery mess. Because before it can draw that amount of current, it'll basically turn off the current, right? So if a short happens for whatever reason, maybe on a board on the other side, water got into a box and it shorted out the RJ45 pins on the other side, well, that's why we're testing on the other side. 55 volt is a lot. Yeah, exactly. So even if water got into your box and it shorted out the other side pins over here, the protection is actually on the board that is on the inside, and that will prevent power from then traveling over the UTP cable. So I think that is the safest ways to do it. You could also build protections on the receiving board, but I think that's less useful because you want to cut off the supply instead of the receiving side, right? And that's exactly what we're doing here, per pair even. So even if just one pair gets shorted, that pair will get disconnected from power. And yeah, I think that is a safe way to do it. Because I'm all for safety in that sense. All this anticipation and no smoke or fireworks. Yeah. I guess I designed it too well. Okay. In the end, I'm testing this to make a product for sale. And it might not be this product, but although this might be pretty close, but I haven't yet, Maiko, but oh, it was for someone else. But yeah, well, I'll certainly try later. I'm going to take a look at the other board, see how many components are involved. I don't think it's that many components, and then we'll do it today. Who am I kidding? Let me check something real quick. Right, okay, let's turn this all off. Checking the board. Oh, I'll check that out, Maiko. Right, so this is the other board. Yeah, this is mostly through-hole. So that's going to be easier to solder. There's not that much through SMD on here. Let's do it. We're going to do it. Oh wait, I do need the stencil. If some of you guys are willing to stick around, we'll do it today. Yeah. Okay. And it's mostly components I have over here anyway. So that should be pretty easy. Meaning you will get up at 3 p.m. That might be a, consequence of this action. I just went on vacation with her. Think she'll be okay. Like this? No. Like this? No. Yes. Oh no, it's too wide like that. Okay. I'm not used to the boards being this big. Your resolution was lowering to thumbnail quality? What? Let's apply more light. Well, I guess this should stick. No. Wait, what? Let's get that aligned. That should be good. $240p, man. Okay. There. That should be good enough. Still see a little bit of red. Yeah, okay. I'm not sure how I'm going to spread the paste on this one because it's really spread out. I guess like that. A little bit more over here. Okay. Oh, sorry. I need to align the camera better. There. That's better. No, well, no, we're gonna, you know, this guy. Oh, that could have gone better. That's what I get for doing late night soldering, right? Early morning soldering. I guess that's how you look at it. let's get this put away. Let's check how it turned out. Yeah, that'll do. That will do. This is an occasion for the Aussies to join. Exactly. That's why we're doing this. Okay. It's already a 2-day stream. Okay, that's good. Now let's get this put away. Right. Like this. And I need to make a BOM file. It always sounds so bad when I say BOM file, but that's just what they're called. Because I really didn't plan on doing this one today. But, you know. Okay, let's fix all this. There's always more components than you think. Oh no, my multimeter software crashed. Okay, whatever. And there we have components. Let's do it like that. Did I have those here still? Oh, I got my tweezers back out. Um, 1206 capacitors. I'm having a deja vu moment. I do, but they're not cold, so I went for normal Cokes. Where do these go? Oh wait, there's more. Oh, I haven't consolidated this bomb yet. No. Okay. Warm Coke likes to release their CO2. Okay. Any more 1206? No, PTC. Nope. I'm gonna rush through this a little bit. 0402, 0603. Oh, 0603. That goes here. What? No. No, exactly. That doesn't go here. It goes here. I was like, did I mess up a footprint again? But I didn't. And that's it for the 0603s. No, it can't be. Oh wait, that's the resistor. Never mind. So we need some 0402s. And those go there and there, okay? A 1 UF, okay. Oh. Yeah, those pads are a little bit ruined, but we'll see. Okay, done. think that's all the SMD capacitors. Yep. So let's move on to resistors. Nope. And let's get some 24K for my book again. And we need 4. That's 5. Let me see if I can put that back. Good enough. Good enough. Okay. Where do those go? Over here. Yes. Okay. Oh 0402 5.1. You're luring Sion here, okay? Why, am I doing something egregious? There. Okay, we need a 33R. Yes, that's correct, Cyril. It can only control one LED strip. But let's say you have a 5-volt LED strip and you have 600 LEDs, so 10 meters. For that, you'd want a front, a middle, and a end injection. Ta-da! It's also to provide a little bit of versatility, because you can use a 5 volt, 12 volt, or 24 volt buck converter. And if you're using 24 volt, using the 10 amp limited circuit would be way too much. But a 5 amp is still, you know, pretty good in a good ballpark in that sense. So that's why I wanted to have 5 amp and 10 amp output. Because a general edge injection will do 4 amps, and a general middle injection will do 8 amps. And it doesn't matter what voltage that's at. So for this board, I can put replaceable fuses on here. But I'm thinking I might just deliver it with PTCs also for the LEDs. And it would be the first board I'm doing that on. But then I can pre-configure it, basically. Yeah. Oh, lots of diodes. Let's see here. 6. Magnifying glass time, because I need to know the orientation. Well, maybe. That's a good point there, Cyril. But that will, I think that should be something that's in the documentation then, not so much on the board itself. Because there's only limited space of things I can put on the board. Let's see, do I still need resistors? No, I do not. Good. Resistors be gone. They go here. And let me get my box of LEDs again. There. And instead of the blue that it says we need to use, we'll use the green again. Because I think actually I like that better. Yeah, I know, and I'm already dreading trying to remember how I did it last time, and then I had to move them around. And again, I don't know the orientation, because the markings just don't make sense to me. But I think I'll do it the other way that I just did it. Stupid LED. There. Eyes still open, don't worry. Nice. Let's do... I need some red LEDs. Should have some here. Yes. Sorry, I guess it's less boring, or it's more boring actually when I don't talk a lot, but maybe I just need a little bit of drink. Red to differentiate with the other boards. Yeah, I tried to keep some kind of color scheme, but it's getting messed up a little bit at some point. But especially since there's like power involved, I'm like, yeah, let's make them red this time. Or rather, high voltage power. Or moderate voltage power, I guess I should say. Right? Okay, those LEDs are in place. That's the red LEDs. Then I need an orange 0603. And I'm going to use a green one. So this is orange. Okay. Yes. There. Voltage drop of LED depending on color. Yeah, I know. What are you saying? If you'd use a 2.2 volt and non 2.2 volt color, you'd need other resistor value. Yeah, I know that. But the resistor value is an estimate anyway in this case, so. And I kind of like the green with the 24Ks. It lined up pretty well with the orange LED also on there. Likely half of these LEDs will need to get turned around again. I'm so bad at that. Okay, let's see here. Let's do this one real quick. No, I find them very confusingly labeled. Oh. Okay. Before putting them on, I could, but I think I have them on right, so I'll do it after. Let's get these diodes. Oh, I need to find those. Okay, that's a 1N4148. Nice. Got them. Now these are really small buggers. Don't flip upside down, please. Wait. Let's check orientation again. Yeah. Orienting these the wrong way around would be bad. Yeah, they like to lay on the back. Yeah, I don't like this package, but, you know. Okay. We need an LDO. That's this guy. There. Okay, and then we need a few type of fuses. Right? Okay, so yeah, okay. We're starting to get there, which is good, because my energy is running a little bit low. We need a, what was it, a 50 milliamp? Yeah. That's one of the new ones that I should have over here. 300, 100 is acceptable. 500. We're gonna make it a 100 milliamp because that's also fine. Sent me some Red Bull, yeah. Problem is, if I take a Red Bull now, I won't be able to sleep in like 2 or 3 hours when we are actually done. So this goes here, I think. Yeah. Tripping, yeah. Tripping on Red Bull! Okay. Screw terminal socket. Oh, nice. We're almost done. Okay, PTC. No, don't need to do that. So let's make those yellow. Do need to do that one. Okay. You lost my video? What? How did that happen? Indeed. Hello. There. Don't know why that happened. It's a bit warm here. It's like 27 degrees. So maybe the camera didn't like that. No, wrong. Yes. Back full screen? What do you mean? That's good, right? It's working again, right? Hope so. Oh, I moved this one wrong. Yeah. Yes. Chat delay. What? Oh, okay. Okay, now that's done. So that means I think all SMDs are done. Don't touch the cables while streaming. Yes. A brief blackout. Well, it wasn't too bad. So I'm gonna check with my magnifying glass real quick. That should all reflow okay. So let's do that. Now this is a much bigger board, but it should still fit on the smaller, on the small hot plate. Like so. I'll be right back because it's getting way too warm over here. Okay. It's even got spare space? What?
Well, here goes nothing.
Oh, the hot plate got... Yeah, that's true. My garage is connected to the house, yeah, but it is a separate kind of building somewhat regarding isolation and insulation and things like that, but... That was also throwing me off. Hold on. Flip horizontal. There. I should be in this orientation on this side. Oh, we're getting smook. I was also looking at that. I was like, something is off. I just don't know what. Yeah, exactly. Okay, we're at 146, so we can start poking stuff. Because this is bad. Okay. I think that should be it. So let's get that off again. Let's keep the heat plate here, and now let's do the final check with the microscope. Ah, this slightly lower temperature is really giving me back some energy. That's good. Okay. Where are we? We're here. Yes. Okay, so let's check these. Those look great. Those look good. Those look good. That looks fine. Yeah, this one slightly anemic. But it is connected, so that's fine. Oh, that's okay. Yep. Yep. Eh. This could have been better, but it's okay, it's connected. Perfect. Good. So then let's do our multimeter tests for the LEDs real quick. And for the other one, I knew from head how they were connected. So for this one, I'm going to look it up real quick. For instance, down here. Thanks, Maiko. let me turn on the multimeter. Okay, so power should be coming in from down here to up here. Okay, that's good. Wait, okay. Yeah, that's good too. And then here, I believe it should be like this. That's good, that's good, that's good. And then over here, I believe it should be like this. Oh, that's hot. Yes, yes, and yes. Good! Ha ha ha! First try! Kinda. No, I didn't put AC on. I opened the door. Because it's a lot colder outside. It just hasn't cool down inside yet. Okay, good. So now we get to do all the other stuff. Your short-term memory worked after the first board, right? Yeah, I didn't make the same mistake again. Okay, so let's gather the components for this. I know these should be 2 of these. And we need an RJ45 socket. And then we need terminals, and I got some new ones. No, also not. That's one baggie. And that's a second baggie we need. So, we need 2 here. 2 here. I also like that color. The brand is in Yilin, I believe, and I like to use that at least in prototyping. For production, I might still go with a different brand. That kind of depends on the pricing. But yeah, I do like those indeed. Also the color. Oh, wow, this fits. Okay, I think. Yes, good. I wasn't sure about that one. That's all custom footprints again. Okay, then we have these. Yes. Oh, okay, I wasn't sure about these terminals if they were going to fit, but they do. Perfectly, I might add. Very good. Labels are also visible still. We have the RJ45 here. And we have capacitors. Yeah, I'll watch out for that. Okay. And then we need to add some PTCs, and that's already it. Yeah, that looks good. So let's do these last. Let's just click this guy in. There. PTCs. Might it be over here? No. Okay. Yes. Yeah, I got them, don't worry. I've used these before on other boards, so. No worries there. Okay. So, we have these guys. Right. So, going by what is shortest, let's put in one of these. And then put in a terminal and see which is highest. Oh. PTC wins. Okay, PTC last. So, the reason why there are 5 amp and 10 amp outputs, basically, is especially if you're doing 5 volt, but also for 12 and 24 volt. Wait, which is higher? The terminal or the capacitor? Oh no, the capacitor's less high. Okay, let's do those first. There. If you're doing LED strips, a edge injection basically will take up to 4 amps or so, and the middle injection will take up to 8 amps or so, and hence that corresponds with 5 and 10 amps. Yeah, this board does allow, with my custom footprints on there, for me to either put on a fuse socket or these PTC fuses, but I'm thinking of maybe delivering them directly with PTC fuses for this board. But yeah, these are 5 amp and 10 amp for power injection purposes on an LED strip, basically. So you need 4 and 8, so that's 5 and 10 amp fuses. Okay, let's get that soldered on. Okay, let's make that a little bit neater. Yeah, but there's actually a reason why I might not want to use the car fuses on this. Because those only go up to 32 volt. And I kind of want to support higher voltages with this board. So then I can use PTCs, which do support those voltages and also below it. So let's get this soldered on. The reason why there's 2 pads here is because I'm not really sure yet which size capacitor I want to use here. And doing it this way, it gives me an easy method to use a different size without having to change the footprint, especially while prototyping. But I might leave it for production, I'm not sure yet. If this will be production, you know. Right, yeah, but these pads are linked together, and they're just to support different spaced capacitors, basically. It's a 5 millimeter centimeter millimeter. I think millimeter spaced or 7.5. So yeah, it's just to make my life a little bit easier. I generally don't like glass fuses, so yeah. And they also take up a lot of space, so. And hey, I mean, if I can get auto reset fuses on there, in theory, that's only better, right? Come on. Okay. So let's see how that aligned, but that looks pretty good. Yep, happy with that. Yeah, it's amazing material, I agree. I know, but I'm using the big tip, and then it's generally fine. Okay, hit all the pads. So that is good. And now we need to do some PTCs. We lost the music. No, it's there. It's just low. This is gonna require some rework. So I'm only gonna do one leg. No, those are not small, but that's partly because it's 5 amps, and they're 60 volt compatible, so that's why they get really big. So now I get to kind of twist them the way I want them. And generally I don't have to resolder them, just have to make sure they're in correctly. Yeah. So, like so. Have to heat up this plane here. Yeah, this is what that T3A station combined with a pretty big tip works wonders. It's really such a big change to what I had before. Okay, I think that's acceptable. I'm thinking I might need to move these capacitors back slightly, so let me note that. Because these PTCs can get up to 125 degrees. Now, these capacitors are rated for 125 degrees, and that should only be a fault condition. But if I can move them further away, that's just better, because then they'll live longer. Right? I have to see, because there's a screw hole here, but other than that, it should be okay. Especially for this one. Right! Let me take off the list. I did these. I know you're not seeing the list, but we did this guy and this guy. We did these. Yep. Yep. And yep. Okay. Yes. Okay. Let me check something else real quick. Okay, good. So let's remove these pesky spikes, and then we can already move to testing. There's still some pointiness here, especially with those screw terminals. On production runs, I have them shave it off, basically. But here, you know, it's okay. Goggles needed for the spikes. No, I have a method for that, so that they don't pop out. Direct connection without testing. Be confident. Well, we're going to do testing in 2 stages, right? We are going to connect it first. Okay, let's remove my let's make space. First we're going to do testing without a buck converter. Last visual check first. No, I mean, this all looks good. Yep. So, wait, no, we forgot something. Oh, no, look at that. We forgot to solder in the RJ45 socket again. Well, it's a quick and easy fix, so let's try it with the big tip. Should work in theory. Just have to keep turning it around. There. For some reason, it has on some live streams, Mako, and on others it hasn't yet. I haven't figured that out yet. It's not the best soldering job ever, but it's good enough. That's the theme of these prototypes, isn't it? Good enough. I should make a t-shirt. Prototyping, good enough. Okay. Well, that was a good idea of you there, Mako, to do a visual inspection. Okay, so now we have everything soldered that we need to solder, I think. Yup. Okay, and while the only way to power this board, it's not really true, is by RJ45, because there's no power input on here. What we're going to do first is we're going to power it by RJ45 without the buck converter connected. Now, no magic smoke yet, but we are going to prepare. So let's get a UTP cable again. And this will be the output. And this will be the input. Right? And I guess I can do it like this, because my wires are wonky. Just in time, Felix, just in time. So we're going to do it without a data signal and without the buck converter first. Then we'll add the buck converter. And then we'll add a data signal. And in theory, then we're going to end this already 3.5 hour live stream with a success. Maybe. To make pink smoke. How do you make pink smoke? I don't know. I built too many protections in my boards to make smoke. Right, so we have the stupid screen. Okay, hold on. Oh no. Stop pushing my button. There. My cable was pushing my button. Think most of the stuff is still aligned somewhat. There. So, power in, positive, negative. Yes. This is already tested. Goes out here. Comes in here. And then powers up the board, except there's no buck converter. But that's okay. The last live stream was longer, you got this. Yeah, but I am a bit tired. But, you know. Let's not make this not touch. And let's make this go away. Okay. And let's try and connect the multimeter again, although this software... Stupid cable, stop pushing my mouse button. Yeah, the software for the multimeter died. So now I have to kill it, but I'm not sure that's enough. So let's try that. And let's see if I can connect to it. Oh yeah, it did. Nice. Okay. Okay, I'm going to zoom out a little bit. Wait, why is the light on here? Hold on. Okay. Input board, output board, or sender and receiver as I call it. 55 volt, and let's set it to 0.5 amps again. You know, there's 25 meters of AWG 24 UTP cable connected right now. The music is appropriately epic. Okay, turning it on. Oh, look at that. Look at that. I need to turn down the lights again. Turn down the lights. Oh, it's a different song. Right. So now we can verify we have 3 input pairs that are online because the PTCs are open, because if they close, they turn off the light. And we can verify that we have 3 pairs of power coming in. Well, this is the only one that isn't. But here is something that is not correct. Because board power is here. Wait. Can't read it with this on. Right, so incoming power should be lit. Because, well, that's incoming power from all the other stuff. But this is buck power. Why is buck power lit? That's not right. But it's connected to buck output. How is that lit? We have a mystery, dear folks. So let's measure the voltage. Oh, it's in remote mode. Yeah, I'm not sure. So ground, a ground somewhere. Oh, what voltage do we see? Two. 3 volts? From where? No, I just checked the... I mean, it's very simple. There's a resistor here and an LED. And there's a path here on the back, which goes from buck output, right? So that goes into the fuses and things like that. All the way over here. It's this trace. So from here to there. And there's a lot of spacing or clearance on there because it's a high voltage trace without a fuse in front of it. So it's that trace. And it's not connected to 48 volts either, because wait, so in theory, this is buck input. Buck input is about 55 volts. That is correct. That's correct. So, but there's no buck converter on there. So then this should be not connected. Well, no, it's not the biggest deal, and I think it'll light up more once it's actually connected. Yeah, where is it getting 3 volts? I mean, yeah, it's probably leaking through another part of the circuit, and I think I know where. But let's quickly check if anything's getting hot, because that's also an important check to do at first. So just like on the first board, we see that the LEDs are around 47 degrees. Of course, it's traveling through the UTP cable, so there's a little bit of voltage loss there. But that's okay. That's not a problem if that's warm. Then over here is the RS485 chip. That's also, and the termination resistor. That's also going to be warm. That's fine. And other than that, nothing is warming up. Okay, that's good. That is good. Well, I can turn the power off, go into continuity mode. It's a capacitor. It's leaking through a capacitor. It has to be, because everything else is now off because the power is off, and this LED is just slowly dying. Wow, that's taking a long time. But then which capacitor? Because these are on the buck output. It might have something to do with the circuit I have here for the broken fuse indicators. Because those do cross things. Well, that is something that needs further analysis in the future. Because what we're going to do now is hook up a buck converter. And I think we're going to go with a 5 volt one. I should have a 5 volt one. It's still there. It's still lit. Is it over the UTP cable? No, it's local on the board, right? So we have a this one here. It is a 48 volt, but it'll take up to 60 volt. That's important because we're feeding it 55, and it's a 5 volt out, and it does 75 watts in total, so 15 amps, right? 15 amps output. And the way it's meant to be on the board, but we're not going to mount that today. I'm going to play with that later on. Is this way. But then spaced like so, because then the terminals here are still reachable. The labels aren't anymore. Need to think about that one. And then these cables will just hang over like so and connect into that terminal there. So that's the idea. So I need to flip this over. Yeah, direct is if you want to make a bridge here, and then you can use 48 or 55 volt directly. Well, the buck converter will likely light up that LED more. Yes, but they're not lining up perfectly, so... No RS485? No, we'll hook that up in a minute. Don't worry. So let's hook these up. And I need to make sure I clamp down on the actual conductor and not the plastic. I've kind of already decided to replace these terminals, but we'll see. Since the board is so big, they're actually okay, I think. But yeah. No, this is a non-feral day. Okay, and this is the input. Right, so again, the idea is that in the end, the buck converter will sit like so. These terminals will remain reachable, so you can still screw in output wires, data wires, and things like that. The fuses will be under here, that's fine. And then this will just neatly, you know, tuck away on top of it. So it's a pretty neat, tight little package. Now only this this green one here for buck power, that one shouldn't have been lit. Okay, let's put on the glasses again. Whoa. Okay, and power. Okay, now it's more lit. Well, let's see what voltages we have now. Are we in voltage mode? Yes. So buck input is 54.6. That's fine because we have a little bit of voltage drop because of the cable and things like that. And buck output is now 5.14 volts, as we would expect, because we have a 5-volt buck converter, right? And this resistor is 2.2, and on the input it's 5.14. What's coming out of the buck converter? So that's correct. Now let's see what's on this positive output. 5.14. This one. 5.14. And this one. 5.14. Great. These are all ground. Oh wait, no. Oops. That's data. Well, it was 5 volt. That's not... Okay, that's okay. So ground. 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 Okay. That's fine. Now, what test do we want to do first? Do we actually want to see if we can light up some LEDs? Or do we want to test the functionality of these LEDs? I kind of want to test the functionality of those LEDs. But I'm going to do that in the safest way. And that's by screwing in a wire. I turned off the power, but it's not turning off. It's actually 55 volt. And then at the end, with the buck converter, you can determine if you want to use 5 volt, 12 volt, or 24 volt LEDs. Or 48 or 55 volt if you have those or whatever. Yeah, and then everything is transported over a single UTP cable up to about 100 watts for 50 meters. That's the calculations right now. I still need to do practical tests. For 100 meters, you'd likely be limited to about 80 watts or something like that, or 75, let's say. That's still 15 amps at 5 volts. So, okay, let's screw in this ground wire here, or this wire into ground here, and I'm going to loop it around. I'm going to blow it up first before actually using it. And put it into this positive terminal here. Yes, you would use a 55 volt sender PSU. Yes, correct. I have those, but I have a bench power supply which goes up to 60 volts, so I'm using that to do my testing. So now we made a loop between ground and one of the positive output terminals that's behind the buck converter. But there is a 5 amp PTC here. So in theory, this should be limited to 5 amp and then cut off. And then one of these LEDs should be lit, indicating that a fuse has blown or is shut in that case. Or, what might happen earlier, but probably not, is one of the pairs in the RJ45 cable turns off because these PTCs are triggered. But I think it'll be this one. I don't know. How many watts have you used? 5. I'm going to keep my glasses on. I'm still a bit darker, you know. There. Okay, we're going to set the limit to 5 amps. So this board can take in 5 amps if it wants to, but then there's 3 PTCs here which will limit it in the end. And then it'll send it to the buck converter, which will then send it to here and power. Uh-oh. Okay, it's not liking it. Oh, and this isn't all... this... Okay. It took a little bit of an error state, but now this LED is lit, which means that this PTC... Okay, yeah, it's hot. Is now shut, and the others are still delivering power. So we can verify that. So ground, I need a ground somewhere. This should still have 5 volt. Yep. This should still have 5 volt. Yep. And this, it doesn't have any voltage at all anymore, because there's a shut there and this PTC triggered. Now it didn't trigger instantly, so I'm going to turn this off again, and I'm giving the board 10 amps to work with. So we're giving it 550 watts. No, I shorted it on purpose, so that's this wire here. Right? You don't see a shorting wire? Hello? The PTC wars. Yeah. So now it has 10 amps, so in theory it'll maybe trigger faster, or maybe it'll trigger this one. This is all things, you know, I'll be testing to see if the design works. So let's turn that on again. Oh, wow. Okay. Yeah. It just instantly triggered. Right? So this is an output indicator that a fuse is blown. This is a circuit from a DIG Octa. The DIG Octa power boards all have this feature. But then combined with a PTC instead of a real fuse. Then again, if I release this design with a real fuse holder in there, but they're under the buck converter, at least you can at least see that that fuse is blown at that moment. That's basically what that light is for. Because it was power limited. So the fuse, the PTC blows much quicker if it can draw basically an unlimited amount of power. Let's try the other 5 amp channel. Because you think like, hey, wait, 5 amps? That's a lot. We're using a UTP cable. That's right, but we're only allowing 3 times 750 milliamps, so 2.25 amps in total over the UTP cable. Then it goes to the buck converter, and the buck converter can do 15 amps. So, yeah. Okay, so let's hit it again. This is now on the other 5 amp channel. It's flickering, it doesn't... And it's gone. Okay, good. Ah, I know why it's flickering. So this guy is flickering because that's the buck power. And that is the buck output power. So it's actually the buck converter that is limiting, not my boards. Right? Because my boards can transfer about 2.25 amps at 55 volt. And the buck converter can only do 15 amps, and the short is probably taking in that 15 amps until the PTC shorts, and then it turns off. So my board isn't flickering in that sense in this case because I can draw enough power from the central board here. And that remained online because otherwise these pairs would have turned off, right? Because we verified that. Yeah. That basically works as designed. Good. That's quite cool. So let's disconnect that and have a little bit of fun. So the receiver won the war. Probably. I'm just going to jam this cable into this one. Yeah. I did see it dim very shortly, didn't we? Let's try it again on the other one. No, this one's still too triggered. Okay. So then we have to wait, I guess. To cool them down. Okay. Still hot. I don't want to try the 10 amp one. It'll work, but... Okay, let's try it again. Yeah? Okay. That works. Cool. Yeah, exactly. Are there temp issues? No, not really. Last thing we're going to do is we're going to put a data signal in here and an LED strip on here. So let's take a, I don't know, what is this? 5 volt, that's fine with me. Let's take a little output wire here. Yeah, well, that's the idea there, Imam. So, let's give it some ground. Yep, then we have a data wire. Well, Tikiter, that is correct. But it's kind of on purpose also, because I don't want to know that the fuse is working. I want to know that the fuse isn't working. So that's why those lights only light up when the fuse is blown. Because if the fuse is doing what it should do, I don't need to see a light there because it's working. That's my reasoning behind that. But for these... you kind of do want to know power is coming in or going out. So that's why those are lit when there's power on there, and they're not lit when there's no power there. So if you, for instance, have a bad UTP cable and only 2 of the 3 lights come on, you know, hey, something is wrong there. But I get that that reasoning might seem reversed then from the other reasoning. That's how it kind of worked in my head. Right, so we have a 5 volt LED strip over here. And 5 volt LED strip, receiver board, UTP, it's just 25 meters right now. 5 volt output converter, that's good. Then we have the input here. Now we just need data. Do I have a dig quad or something already? Yeah, I do. So this is already pre-configured. I don't need positive in this case. I've lost my screwdriver. Ah, here it is. This can go. Oh wait, this can go too. Hold on. Well, using differential isn't new. Like the cult boards and the Falcon boards and stuff like that do it too. But having power available, and for the price point I'm hoping to be able to release this, it would be pretty good, I think. So right, so what I want to do is I want to take 5 volt from this board, from our sender board, and power the dig quad. We'll do it using 5 volt EXT just for fun, because we don't really need main power, we just want level shifted LED output. Yep, still working on that full time. It's more doing board design and things like that, but still. That didn't work. One moment before we do that. Okay, so let's get this in there. Hey there, House Wolf. Yeah, well, I'm not calling it PUE. I thought we were calling it QoE, or, well, I'm calling it power diff. But yeah, this is doing a data signal and power over Ethernet or RJ45, you know, unshielded twisted pair wire. Hold on, I need to pay attention here. VXT. Now, these other terminals don't work that well without a ferrule, but we'll try. That's okay. Right, so the reasoning behind this is this will give us 5 volt output to power our dig quad, or especially the ESP in this case, and the level shifters, which will then provide the data signal into the sender board, which will then send it to the other side. Yeah, one cable for both power and data. And we're sending 55 volt, which we can transform into 5 volt, 12 volt, or 24 volt at the end for whatever type of LEDs we're using. Right, so now this looks kind of funny here, because this is basically a little loop, But that's that's the purpose. We have our LED strip. We have our receiving board, buck converter. We all verified that works. Power. That seems good. Let me check if I have something connected to my Wi-Fi. I do. Okay, let me change the color order real quick. There. Now we have our, the orange we know and love. I guess I can take this off. So can we change the brightness? Yeah, we can. Noise. Let's make it do some kind of effect. Oh yeah. So this is all being powered off of the 55 volt supply, because this board is running off of the power supply of this board, because this board doesn't support 55 volts, so that's why we have a 5 volt out. Making funny. No, it's my power supply that makes that noise. So let's see if anything's getting warm. Right, okay, you guys want to see too. So on the receiving board, on the receiving board, no hotspots except for the termination resistor, like we had before, and the pair LEDs. And on the sender board, that's the ESP. Right, we have the RS485 there, that's 43 degrees, and then you have the LEDs, those are 50 degrees, just the same as before. Inductor is slightly warmer at 37. That's okay. Yeah. Okay. Is there any power limiting going on? No, power limiter is off. So let's see. We're currently drawing 10 watts. Okay, 10 watts, 55 volts. So that's 0.18 amps. Let's set it to solid. Full power, and then white. So now we're drawing 25 watts, but it's still only 0.47 amps. Well, you can see well, you can't really see voltage drop there. We can try and make that worse, but I'm already very happy with this result. I need to find a certain cable. This is currently 25 meters of AWG24, so Cat5e unshielded, normal, unshielded twisted pair, and 24 gauge solid wire. So very normal, run-of-the-mill Ethernet cable, right? Nothing special. Let me try and find a certain plug. I found it. Because what we're going to do is we're going to power inject it here so that we can use a bit more power. And that's why I'm debating of maybe making a smaller version of this board, because you're not always going to need 20 amps of power on the other end, right? It's kind of overkill, maybe. Because if you just want to run a prop or a few, like one strip of LEDs, you don't really need a 15 amp buck converter, but yeah. Yes, well, not Cat 6 or Cat 7. That really doesn't matter. We tested Cat 5e up to 500 meters for the data signal. But I also have I can't get it out right now. I am going to do tests with AWG24 and AWG23 cable. And in theory, the 23 cable has larger conductors, so it'll have less voltage drop. But the theory as I calculated and designed the system is that we can do about 100 watt of output over a 50-meter cable. Less cable, more output. More cable, less output, basically. But still, if you can do like 12 or 15 amps with a 100-meter cable, bam. Okay. Now let's set it to solid again, full power, and white. Okay. Because we now have dual injection here, so we've injected the front and the end of this 5-volt strip. We're now drawing about double, 46 watts or 0.85 amps in total. So this isn't really taxing anything. Yes, RJ Riemann Snyder. I recently finished the design basically, and I'm currently costing it out and trying to set up production and things like that. So that will get produced. This is a mobile phone. Yeah, this is an S98 Pro, which has a thermal camera built in. We can take a look again, but the LED strip is going to be the hottest point. Middle injection connection. No, then I have to solder it in the middle of the strip, so that's not going to make sense. Right, so now if we look at this, we can see the two PTCs. These guys over here, they're 46 and 49 degrees. That's normal because they're letting power through to power the LED strip. Over here, anything else? The board is still cold, nothing going on. Over here, same thing, nothing going on. Yeah, this is getting warm. This is now 52 degrees. Okay. Last test, and then I'm going to call it quits and probably do the rest of the testing on my own at some point. This was 25 meters, right? Yeah, it's a decent amount. Okay. We're going to hook up this. This is my head. This is 100 meter, one straight cable of normal Cat 5e. I crimped it myself. AWG24. No, not breaking out the box. This is verified 100 meters, right? Using the codes on the strip itself. Okay, so we're going to hook that up over here and over here. Nice. Okay, let's hit solid white. Still doing it. Remember how I said we just had 47 watts going in? We now have 51 watts going in. That's because, and 0.9 amps. That's because we need to put more in, because more is getting lost in the cable. Now, normally you'd have a voltage drop issue, because, you know, you're losing voltage on this cable. And we can actually verify that by seeing what our incoming voltage is right now. So I need ground, and I need this guy over here. So we're only getting 49 volts in while we're sending 54.8 volts, right? So 54.8 volts is going out of this board, and then coming into this board, we're seeing 49.25. Now, one thing I wonder is how well is it split over the pairs? So the middle pair is 49.25. This pair is 49.27. And this pair is 49.27. That's pretty good. So we're losing a few volts, but hey, that's fine, because although this voltage is now lower, 48.7 instead of 55, which we're setting in, we're buck converting it anyway. And that makes a steady 5 volt. So even though we have 100 meters of U2P cable on there, because we're pushing it through a buck converter, it doesn't matter. We're just losing power. But, you know, that's fine. As long as our output's stable. So let's not try to fry this LED strip. So, great success. Not yet, Vincent. I'm still debating on how to build the whole differential system. Also, if like these midpoint boards or these midpoint boards and the sender 4, and I also have these single channel senders and receivers and things like that. I'm basically building out the system with all the variants I'd like to have, and then I'll release something coherent and which makes sense. Yes, this is a 5 volt output buck converter. This is a 12 volt output buck converter. And this is a 24 volt output converter. So yes, you can run 5, 12 or 24 volt, whatever you want. Same board, just different buck converter. The buck converter in the end will mount on top like so. So it'll be a nice, neat stacked package. And yeah, plenty of power available. Okay, thanks for hanging in there, Maiko. See you later. So Vincent, for now, this will be an extra on top of the already existing system. How I'm going to do that in the future, I don't know yet. Well, House Wolf, that's kind of the idea. And I guess I can share one secret. This is a sender 1. It's called a sender 1. Maybe at some point there will be a sender 8, which will have room for 8 or maybe 12 or 14 for power injection or something like that. UTP cables. And then you can indeed just run one UTP cable to your prop, have this guy in a box or a smaller version maybe, and that's it. No power needed. And then centrally you'll just have like a 1000 watt 55 volt power supply, which will feed everything. Now, mind you, that's not going to be the cheapest system out there, right? All this hardware costs money. And if you're willing to put in more effort, you can save money by putting a power supply locally or whatever. But I think it's a good option to have available, right? For some situations that might call for it. If you need power for a few LEDs or whatever 100 meters away, you don't want to run AC cables and things like that. Well, this is very easy cable to run and to terminate yourself, and, you know, yeah. It could be that they're 12 volt Neil, but it doesn't matter. Then you get a 12 volt buck converter and it's 12 volt. What will you use for power? This is powering the LED strip. So if I do this, it dies because there's no power coming in anymore, right? If I do this, it instantly works again because now there's power coming in and data. Exactly, Housewolf, yeah. And I mean, this is now a very big receiver board because it's designed to do up to 100 watts of output. I could easily make this half the size or even smaller to be at a prop, right? I'm already thinking about that, of course. But I wanted to do the big design first because if I can make the big design work, like a 100 watt version, I can easily make a 50 or a 25 watt version, right? Nice there, Ole. Thank you very much. That's correct there, Neil. We're using 55 volt over the UTP cable. And then whatever we receive, currently we're receiving... let's see what we're receiving. We're currently receiving 53.9 volts. But if I change the effect to, for instance, flow, we're receiving 53.7 volts. But if I then up the brightness, let's go max power, we're now only receiving 51.6 volts. So there's going to be massive voltage drops here, but that's calculated into the system because our output voltage is always 5 volt. So it doesn't matter that we have drop on the input. Well, the cable will get a little bit warm, but it's limited to what I deem safe, for instance, and so you can't really exceed that to keep it safe. But yeah, I mean, that's the idea. And you can choose if you want 5 volt, 12 volt, or 24 volt at the end. Or 48, I guess. Well, that's what I hope, Tracy. I mean, I like designing stuff of which I think makes sense. Yeah. I'm just playing with the LEDs now. And I mean, I get that this is the big 100 watt solution, but you can get so next to these big buck converters that will do 75 or 100 watts, you can also get like these, which will do 30 watts. And 30 watts is still pretty decent. I think you can get up to 50 watts, I'm not sure. But this will be 5 volt 6 amp output. And, you know, I can design a board that's much smaller to house these, like so. And then you can easily put that near or inside a prop or whatever. And you just connect the UTP cable and you're done. You're going to wire your new house with UTP and your receivers. Okay, well, that's cool. I like how the two big capacitors on here have so much power that if I disconnect this... Oh. Okay, didn't do it this time. Yeah, they remain on very slightly. See that? I mean, these turn off instantly. So the incoming power LEDs. And then the board power and the buck power turn off slowly. That's funny. What are you talking about there in North Park Lights? I noticed that, yeah. And it's probably because of some capacitors draining, so during normal operation you shouldn't see that. But yeah. That works pretty good. I'm just, you know, trying stuff. Can we hot plug this? Yes, you can. Can we unplug this side? Yeah. Yeah, that seems to work pretty well. And again, this is 100 meters. This is this spool over here. That's a decent amount of wire, right? This is 100 meters. That's like what is it? 320 feet? I don't know. Yeah, that's true. Well, since we've been streaming for 4 hours and 16 minutes, I think this is it. Because as I said before, I'm already a little bit tired, and it's now almost 4 o'clock in the morning here, but I wanted some great success. And well, this looks pretty good. Some things need a little bit more refinement, I think, but most of the features on there look pretty good and work. So, yeah. Thank you for hanging out with me and soldering, and, you know, it's fun having you guys along while I'm building this stuff. And I hope to see you back in a next live stream, a video, or maybe on the Discord server where we discuss lots of stuff related to LEDs in the channel. So, thanks a lot. See you later. Bye-bye.